Hello again, and today we're going to be starting 8.4. So for day 1 of 8.4, we're going to be focusing on operations with polynomials. So real quick, let's define what a polynomial is. It can have constants, variables, and exponents combined using math operations. That's one of the key things is that we have multiple operations going on. So within a polynomial, we want to make sure we talk about things like a common monomial factor. So monomial means one term. So an example of that would be like x or x squared or 7. There's a good monomial. Those are all single terms. When we get to binomial and trinomial, then we are adding more terms. So binomial means two terms. When I look at two terms, they need to be separated by addition or subtraction. So something like that would be like x squared plus 5 or 2x minus 3. These are both binomials. And again, these are separated by addition or subtraction in between. And then we have a trinomial, which is going to give us three terms. And that's going to be an example of that would be x squared plus 2x minus 4. Okay? When we talk about our polynomials, we also like to describe them in terms of what's called degrees. Okay? The degree is the highest power or largest sum of powers. Okay? So an example of that would give us something with a first degree. Would be like 7x to the first power. So if I didn't write the 1 there, it would still be a first degree. Second degree could be 7x squared, even if I add more onto that, like 2x. This is still a second degree polynomial. Okay? So third degree will give us 7x cubed would be an example of that, but this is also one. If I do 7x squared, y to the first, plus 2x to the first, y to the first, plus 5. If I look at my highest sum of exponents, so I have 2 plus 1 is 3, this is a third degree. And just for the fun of it, one last time is a 0th degree. That is real, that would be like the number 7. The reason why it's called a 0th degree is because I can write it as 7x to the 0 power. So therefore, that is a 0 degree polynomial. So today, now that we've defined those terms, we want to look at our different operations. So we'll start with addition, lead into subtraction, and then do some multiplication. With addition, you've probably done this plenty of times before, we need to combine like terms. For me, my strategy is I'm going to go through and highlight every one that is like in a different way. So if I look at here, 3x to the 5th. If I scan through my polynomials, I'm going to look for, here's another x to the 5th. So they both get an underline. Okay? I'll put a circle around x cubed here. And I'm going to look through and, there's another x cubed. I'll put a circle around that. And then I have x squared. I'll put a box around that. Look through, I don't have an x squared. And I don't have if I look here at 2x, there's only one 2x. And then I look here at 1, there's only one number by itself. So I already have my like terms. I have 2 underlines, 2 circles, and that's it. So when I put these together, 3x to the 5th and 13x to the 5th, I'm going to get 16x to the 5th power. Notice my exponent did not change. All I need to do is add the 2 coefficients. Sorry about that. That's another term we should know. The numbers here are called coefficients. So coefficients are the numbers that are attached to our variables. So I have 16x to the 5th. Then I'm going to look at my x cubes. I have negative 7 and negative 10. They come together as negative 17x cubed. Everything else that does not have a matching number will just go in and be added on here. So I have 8x squared plus 2x plus 1. This problem is done. That's as simple as I can get. If I want to do subtraction here, okay, what I'm going to do is I'm going to focus on this second version. everything after the subtraction sign, since I have parentheses there, I am subtracting everything inside this set of parentheses. So I'm going to go ahead and rewrite my problem. I'm going to have 13x to the fourth plus 8x squared minus 10x plus 6. But what I'm going to do is I'm going to take the negative version of every single term inside the second set of parentheses. So I'm going to have a negative 5x to the fourth, negative 6x squared, and a positive 13x because I'm subtracting a negative. Now that I've done that, I'm going to do my same exact strategy as before. Here I have x to the fourth, x to the fourth. And then I have x squared and x squared. And then I have a negative 10x and a positive 13x. And then 6 is all by itself. So I put together my underlines. I have 8x to the fourth. X squareds go together. That's 8 minus 6 is a positive 2x squared. Negative 10x and a positive 13x is going to be a positive 3x. And then positive 6 in the end. And just for the fun of it, what I have here is what's called a fourth degree polynomial. Okay? Once I hit above trinomial, so I have 4 or more terms, I just call it polynomials then. So next step is to do multiplication. Multiplication, I'm sure you've heard it, is we're going to be doing distribution. So what that means is every single term on the inside of my parentheses is going to be multiplied by this outside term. I'm sure you've done it like this, where you do something like rainbows, like that. Okay? So what's happening is we're going to have negative 5x to the fourth is going to be multiplied by 6x cubed. Then we're going to have a negative 5x to the fourth multiplied by a negative 10x squared. And then a negative 5x to the fourth is multiplied by a positive 4x. And a negative 5x to the fourth multiplied by a negative 8. Every single term on the inside of parentheses gets multiplied by the same value. So thinking back to our unit 7, when I multiply here, the negative 5 and positive 6 get multiplied to a negative 30. When I multiply x to the fourth times x to the third, that means I'm going to add these exponents. Okay, 4 plus 3 is going to give me 7. We're doing multiplication of the same base. I have negative 5 times negative 10 is going to give me a positive 50. X is going to be raised to the 6th power. Negative 5 times 4 is going to give me a negative 20. X to the 5th power. And then my final one is going to be a positive 40, x to the 4th. That is our basic distribution type of problem. And that's distributing with a monomial term. Here we're going to distribute with 2 binomials. The concept is still the same. We're going to take each term on the first one here and multiply it to both terms in the second. And this is what it kind of looks like. So I'm going to have negative 3x times 2x plus 7, and then a negative 5 times 2x plus 7. This is what happens when we do our distribution. So now I'm going to take negative 3x, multiply that by 2x and 7, and then negative 5 times 2x and 7. So I'm going to get a negative, hello. So you can see that it's going to be a negative 6x squared minus 21x. And then I have a negative 10x here and a negative 35. Once I've done that, you notice I have 2 terms that are like terms. They both are x to the 1st power. So let's put those together. Negative 6x squared minus 31x and minus 35. So this is one method of doing it, where every term is distributed to the other 2 terms. The other option that I like to do is what's called a box method. If you try to picture, I have 2 binomials, meaning they are 2 terms. So I'm going to create a box that is 2 by 2. And on the outside of that box is going to be 0.5x and 10, and then 2x and a negative 0.25. So when I multiply here, try to imagine that in this box, every single little box, each of these 4 squares, represents an area. And that area is made up of the terms on the outside. So for example, in this first box right here is going to be 0.5x times 2, 2x. When I do that, I get x squared. And then I'm going to do 10 times 2x is a 20x. 0.5x times a negative 0.25, and give me a second there. Having a little bit of trying to remember my multiplication. Okay, and that's going to give me a negative 0.125x. And then I'm going to finish with 10 times a negative 0.25, and that's going to give me a negative 2.5. What's nice about the box method is it's very easy to identify my like terms here. Here are my two x's. So now I can put these two together, and I'm going to rewrite this as my trinomial. X squared, sorry about that, plus 19.875x minus 2.5. One other advantage of this box method is that you can do this with any number of terms. You could have done it with our monomial to any of the other, like to a trinomial. All you need to do is make a box that matches up the dimensions of the outside. So for example, here I have a binomial and a trinomial, meaning it's a 2 terms by 3 terms. So my box that I make is going to be 2 by 3. So for the 2 terms, I have x and negative 7. For my 3 terms, I have 2x squared, negative 4x, and a positive 11. And once again, I'm going to go ahead and multiply through. So I have 2x squared times x is going to give me 2x cubed. X times a negative 4x is a negative 4x squared. And 11 times x is 11x. And then I come to the next row. I've got negative 7 times 2x squared is a negative 14x squared. Negative 7 times negative 4 is a positive 28x. And then 11 times a negative 7 is a negative 77. And again, in this format, it's very easy to see what lines up on these kind of diagonals. So when I start putting those together, I'm going to have 2x cubed. A negative 14x squared and a negative 4x squared is going to give me negative 18x squared. Positive 28x and 11x is going to give me a 39x. And then I'm end up with a negative 77 in the end. So again, today, what we're focusing on is our operations. We have addition or subtraction, which you are just putting together the like terms. Be careful with your negative signs because sometimes you'll have to subtract an entire polynomial. We can also do multiplication, which is basically we are saying is distribution. By distributing, you're taking each term multiplied by all the terms in the other polynomial. Okay? And that concludes our 8.4 day 1.